the heart of our discussion that we wanted to have today. And if you read the announcements, we're going to be talking about gaps, but we're in particular going to be talking about them in the context of societal benefit areas. So as I mentioned, we had our team leaders meeting last week or last month. Will and Sally and I sat together, also with the environmental intelligence team, and with some of the other team leaders, and really tried to focus in on what a good organizational strategy for the year ahead would be. We're going to be posting what we think the layout of our meetings is going to look like over the course of the year. But one thing that we know for sure is that we really want to build upon this idea of societal benefit areas. We talked about this work last year. Steve Lev and Jason Gallo came on to talk about the work that the International Sustaining Arctic Observing Network group, SAON, had done jointly with Sippy, their institute, in developing and identifying societal benefit areas, which are these sort of broad value-based areas that can help us to organize any system of thinking, but in particular, as we're thinking about the system of thinking, the framework of thinking we need to develop more coherent approaches to an Arctic observing network. This really seems like a key organizational tool for us to return to. And one of the things we're going to talk about today is its flexibility to do different kinds of things and be applied in different ways. So I just wanted to say that by way of introduction, both to the topic for today, but also the topic for the year. On our last call, we did some outreach and said, if you have some ideas that you'd like to see on the agenda this year, please let us know. We're still kind of putting the finishing touches on our plans and shaping those things. We would love to hear from you. We would love to sustain a committed group of people who want to return to this call and keep developing ideas together. And we think that the sort of progress we can make on a broader framework for Arctic observing and the role of societal benefit areas in that is going to be one of those unique things that we can do in the IARPIC space. And so we really encourage you and invite you to attend as often as you can, to bring your ideas and make suggestions for future meetings. And so with that, Jason has a presentation prepared, so we'll let him share his screen. Or Jessica, were you going to run the presentation?
I think Jason's got it.
Okay. Oh, sorry.
Emily has it.
Oh, Emily has it. Okay. And so Jason is joined today, I was going to say, by Emily Silek-Glassman, who's also with the Science and Technology Policy Institute. The two of them are really co-leading the Arctic part of this effort, and we'll be happy to hear what they've got to share with us today.
Thanks,
Great.
Cindy. So, you know, as you mentioned, Steve Lev, our colleague, and I talked to this group previously, and we talked to several other groups. Steve is now a Congressional Research Service, so he's thinking about these issues on the legislative branch side. So Emily is going to kick off this as part of the presentation. We want to update you from where we were last year to where we are now. And some of you know Emily, but by way of introduction, Emily, I'd ask you to say a little bit more about yourself for the group and then kick off the presentation.
Sure, great. Well, I guess I'll start out by first introducing, let's see, us as an organization for those of you who aren't familiar. So the Science and Technology Policy Institute is a federally funded research and development center that supports the White House Office of Science and Technology Policy, or OSTP, and other executive branch agencies. So both Jason and I work with OSTP to support a lot of our Earth observation related work and Arctic science, among other topics. We developed the methodology for and conducted the 2016 National Earth Observation Assessment and coordinated the development of the International Arctic Observations Assessment Framework, which was released in 2017, and I'll talk a little bit more about. And just a little bit of introduction for myself. So I've been at Sippy for about 4 years. My academic background's in physical chemistry, spectroscopy, and biophysics. And as I mentioned, I do a lot of work in our Earth observation, Arctic work, and also in a lot of our climate and resilience projects. So I'd like to give a little bit about background on the International Arctic Observation Framework. So essentially, the Arctic Observing Summit in 2016 called for the implementation of a pan-Arctic observing system. And as Sandy mentioned, in January 2017, Sippy, along with SAON, held a workshop to help develop a framework for what an international Arctic observations assessment could be. So the goals of an international Arctic assessment could include developing a census of the Earth observations relied upon to provide Arctic societal benefits. And we could imagine those censuses being developed within specific national contexts, such as a US census, a Russian census, et cetera, regional contexts or local contexts. We also have methodologies that we can employ to assess the relative impact of individual Earth observations, regardless of source. And I say regardless of source because in the case of the US Earth observations assessment, we've looked at all observations that are used to accomplish objectives, regardless of whether they come from federal sources, academic sources, international partners, et cetera. We can identify the multiple pathways through which Earth observations contribute societal benefits. We know that sometimes the way they contribute benefits is being used directly in products. Sometimes it comes through outputs from large models. Sometimes observations are used as reference measurements, and sometimes they're only used in combinations with other observations. And in general, all of this assessment activity can provide an evidence base for informing decisions, developing priorities, determining where continuity issues are most important. And as Cindy mentioned, we did use this framework of societal benefit areas, which are these broad thematic areas that describe the ways in which we expect benefits to be provided in the Arctic. So I'm showing just a picture of the framework on the left. The 12 different societal benefit areas that are developed, I'm showing in the middle, and they range from disaster preparedness, food security, infrastructure and operations, to down at the bottom, weather and climate. So this framework was developed through a workshop in January 2017. We hosted 48 subject matter experts from 9 different countries, and all of those folks worked on fleshing out a value tree that I'm going to describe next. So the assessment framework is based on a value tree framework. The idea of the value tree is that we'd like to trace the Earth observation inputs, which I'm showing at the very bottom here, all the way up to the benefits that they are used to achieve. So this value tree framework, we rely on expert domain knowledge to build out each of these different levels and to really establish all of those connections robustly. So in the case of the Arctic framework, we had 12 societal benefit areas. At the workshop, those were fleshed out into 41 thematic sub-areas, and underneath those sub-areas, a total of 163 key objectives were developed. I'll walk through an example just to show it in a little bit, make it a little bit more concrete. So one of the SBAs, or the societal benefit areas, was infrastructure and operations. One of the thematic sub-areas within that is the operations and maintenance of infrastructure. A key objective that's used to achieve those benefits is support economic optimization of operations. So all of that material was developed during the framework. It was in the framework development. From here on down, I'm just going to discuss a notional bottom of the tree because we haven't built that out yet. We can imagine that one set of key products or services that are used to support economic optimization of operations are sea ice forecasts. An example of a sea ice forecast is one that comes from the polar sea ice model. There are many different inputs that go into the polar sea ice model, which are not directly Earth observations, but a derived product. Examples include the global forecast system model, the analysis of global sea ice concentration, et cetera. And if we broke each of those models down to the inputs that go into them, we get the Argo floats, NextRad, GOES Sounder, MEDOP AVHRR, Terramodus, and lots of other observations. So what I showed before is one branch of the tree, but I do want to emphasize, and we'll build this out a little bit more in subsequent slides, that in each SBA, we have multiple sub-areas, and for each sub-area, we've got multiple objectives. So here I'm showing an example of the disaster preparedness societal benefit area. The team that worked on it during that workshop meeting split it into 5 different sub-areas ranging from disaster mitigation to disaster response. Within the disaster response sub-area, we have a flyout here. The 4 different key objectives were conduct disaster response operations in a timely and cost-effective manner, going down to ensure domain awareness for disaster response. So as Sandy mentioned, so Jason and I have been working with Sandy and also with OSTP to think about how we would start to build out the bottom part of this value tree framework. And it's a really massive effort to build it out for all key objectives, for all products, for all observations. They've asked us to focus on one part, on sea ice products. So the idea would be that we'd like to understand ultimately what are some gaps affecting the provision of sea ice forecast products, whether those are observational gaps, data management gaps, product development gaps. But in order to do that, we first need to systematically understand what observations we currently use. So what I'm showing here on the right is if we imagined building out below the level of the key objective. So at the top, the 3 boxes here, I'm showing 3 imagined key product, service, and outcome groups. So you can imagine sector decision support tools, sea ice forecast, and weather forecast could all be types and groups of products that are used to support economic optimization of operations. Fleshing out the sea ice forecast KPSO group, you can imagine that there are 3 key representative products, an Alaska sea ice forecast, the polar sea ice model, and the sea ice outlook. And if we break down the polar sea ice model into its underlying inputs, we get some things that are direct inputs like the International Arctic Buoy Program data, and some inputs that come in via modeled outputs or other intermediate products. So one thing I'd like to point out is we know in this case that an individual input like the NOAA voluntary observing ships can actually make its way to the polar sea ice model through a couple different pathways. One is through the global forecast system model, and another is through a real-time ocean forecast system. So as you can see, it gets increasingly complicated as we build it out, and we require subject matter experts at every phase. One, to find what the different representative key products are, and then once we have those products, we can speak to the person who produces it to find out what are all the individual inputs. And at this point, I'm going to transfer this over to Jason, who can talk a little bit more about this network of information that we end up deriving.
Thanks.
Jason?
So, yes, thanks, Emily. So as Emily had mentioned, those top 3 areas have already been filled out in the Arctic context through the framework development process and the representatives from the 9 nations that were at the workshop and then subsequently worked together through SAON to complete the report. What Emily had shown before is working down through the bottom 4 layers. And what we're showing here in this animation is, as Emily had shown, an Earth observation input can have multiple pathways to have impact up through the tree. So if we want to understand gaps, we understand what we currently have, by not looking just narrowly at, let's just take one product and look at one input and does it flow in, but if you look at an input, it can have multiple effects on intermediate products, which is that sort of hexagon at the second layer, through direct pathways as well as intermediate pathways. That input can affect 3 other key products. Those can feed into 4 groups. Those can feed key objectives, sub-areas up into 2 SBAs. So we want to understand all of this. And so if we move forward, what we want to talk about is a little bit the Earth observation that Emily had referenced before that we had completed. And the reason to do this is we've gone through a process nationally in the US to understand the Earth observation inputs that the federal government relies upon, regardless of source, as Emily had said before as well. But what that gives us is some information that we have already collected. And that's useful for the purposes of this presentation because, one, we can show you some sea ice information we've already collected, which fleshes out how the tree goes from all the way from the top down to the bottom. But also it shows a little bit of the process of phase 2 and phase 3, which were alluded to in the framework report, which we've brought up a little bit in our previous slides. But it's also that next step of activities that might be considered by this group and others in thinking about the polar year. So the goals of the assessment there were 4 of them. I mentioned before, we want to understand the reliance of the federal government on individual Earth observations. We want to assess the relative impact. We also want to identify unanticipated applications. When we showed you the network before, it is often that we found that a observation conducted by, say, one federal agency is used in products developed by a second federal agency. That may have nothing to do with why the sensor or the platform or the sampling program was either designed or deployed, but may provide additional information such as a reference measurement, which Emily had mentioned before, that contributes to the delivery of societal benefits through those Earth observations. And again, this provided an evidence base for informing decisions. And the Earth observation assessment represented really a census of those systems, sensors, networks, surveys, sampling programs that the government relies upon. I should say these are space-based, airborne, marine, terrestrial, freshwater. They're remotely sensed. They're in situ samples. They're human observations as well as mechanical. So we really wanted to take all of those into account. Next, please. This is just to give you an idea of the size of that study, and then downscoping it for the Arctic, but just to give you sort of a lay of the land. This was a 2.5-year process. Sally McFarland was integral to part of this, as many people have contributed as well. We had about 300 federal subject matter experts on those societal benefit area teams. We did data elicitations with a further 1,000 subject matter experts. That assessment generated 217 objectives. We looked at over 1,700 unique products, so that's end products as well as those intermediate products, modeled outputs. We came up with 1,323 unique Earth observation inputs, but the final number there, the 54,000 nodes, that really represents those 1,323 inputs feeding those 1,700 products, multiple pathways. So again, as we've said, data from a sensor, for example, can be used in multiple products through multiple models, have multiple applications across many, many different key objectives. And on the right are the societal benefit areas that we used for the national assessment. Next, please. And I mentioned before, we can leverage the existing information of these products that we mentioned. A number of them actually are sea ice relevant, and this is what, in working with Sandy and OSTP, we've been focused on sea ice in particular. We can mine the data that we currently have. A lot of this data was elicited by the partners that we work with on the Earth observation assessment at NOAA TIPIO. They do the internal NOAA requirements process, NOCIA, if you've heard of that. We also work with the U.S. Geological Survey and their requirements process internally. Data from USGS, NOAA, and data that we've collected under the auspices of OSTP all went into the Earth observation assessment. A lot of the sea ice products in particular came from NOCIA, and so that's what we're using. So you may have seen some of this before or been an expert that did an interview with NOAA TIPIO folks. So that's where we got a lot of this information. Next, please. Here's all of the products that we were able to pull from our current assessment that had just sea ice in the name. There are other products that are named differently that we could probably add a few more to this list, but this is what we already have. You can tell that there are a lot of these are broken regionally or by specific types of domains, or some by, there's SAR that's being used. So, or the time frame in which the forecast is being, or the forecast time frame that's being produced. So from this, if we go forward, we took an example of one to sort of decompose it to show all of you sort of what goes into a single product. So the polar sea ice model, which Emily had mentioned before, this is a proxy for a couple of the sea ice models produced by the Marine Modeling and Analysis branch of NCEP. And these ones are focused on Northern Hemisphere. So these are Arctic polar sea ice models. But what goes into that on the far right is the KPSO, which we've mentioned before, the key product. Emily, could you click? Then we also have the intermediate products, which we mentioned before. And so you can see that out on the left, that's a whole roster of the observing inputs. Those observing inputs are flowing through intermediate products, mostly modeled output, then going into the output that comes from the polar sea ice model. Next. And then next. So this is just another way of looking at this. Again, when we begin to look at, we have the polar sea ice model as a product. We have, for example, the MODIS on the Aqua satellite. We want to understand how it flows into the polar sea ice model. It's not just one simple path, it's an intermediate path. It's going through 3 different products that we've highlighted here into the global forecast system model. If you click again, you'll see that the 3 different intermediate pathways are giving us 3 different parameters or measurements. So the MODIS sensor is giving us snow, which is going into snow depth analysis. We're looking at wind and clouds. We're also looking at global water cycle, which is how the tropical cyclone gets in there, which goes into the global forecast system model. That modeled output run is then feeding the polar sea ice model. Next, please. Another way to think of this is if you have the column here in the middle, these are the Earth observing systems. So for example, we have the AMDAR program. We're getting both static pressure and temperature from AMDAR. That's feeding the GFSM. So when we're talking to this group and other subject matter experts, if we want to understand parameters and understand what we have, which measurement are we using? Are we using both to go into GFSM for sea ice, or one or the other? We can move on, and if we look at sort of the AMSR instrument off of Aqua, it's the same thing. That we see it's going into 2 different products on the right, 2 different models, a sea surface temperature as well as a sea ice analysis concentration product. And those are the measurements that you're getting off of the AMSR sensor on the left. So sitting down and understanding which measurements from which sensor are being applied to which model when will give us a greater understanding of what we currently have, what we use it for, how it's being applied, and then the pathway up the value tree that we've described to see how that's then being used to address specific needs. Next. And then here's another one, the Coastal Marine Automated Network. Again, a series of different measurements going into 4 different models and products. So the GFSM again, Ocean System Forecast, Global, the Sea Surface Temperature, Tropical Cyclone Vitals Analysis Package. So which one of these measures maps through these products up the tree is what's of interest to us. And this is where we can work with you as a group and associated experts to understand, is relative humidity coming off of this and going into a tropical cyclone analysis package to give us the water cycle that goes into a global forecast model that gets used for sea ice. Is that the right measurement that we should be paying attention to? Next, please.
So,
and I'll hand this back to Emily.
Yeah, so just to connect this back to kind of the flyout diagrams we showed you before, essentially what we've learned from talking with Sandy and from talking with other Arctic experts is there's the desire to connect, to basically have a layer of Earth observation parameters. And I'm showing some examples here on the left: albedo, ice strength, salinity, etc., and to connect those up to the value tree. But that's a layer of information that we essentially don't get from the existing assessment data. So what we would need to know, as Jason said, is to connect what are the parameters that we're getting from what inputs to serve what outputs. So it's really these connections that we would like ultimately to get a subject matter expertise to help us figure this out. So, and I should say that that diagram is notional only. That's not actual data. Sandy had asked us to kind of tee up some questions for discussion. So from talking to some Arctic subject matter, and I should say sea ice subject matter experts, we've heard that the following parameters, among others, are important for developing sea ice forecasts. I mentioned before albedo, flow size distribution, ice strength, ice surface temperature, and others. We're wondering, I guess, could this group help us map between these parameters and the current set of Earth observations that were used to produce those sea ice products? Could you help us identify measurement issues with those parameters? and potentially help us identify applications for the key products, services, and outcomes we've already elicited. And the reason we'd like to get some more information there is because we don't know, for example, if there are products that meet all the different objectives that, that we would expect for coming out from the Arctic Observations Framework. So for example, if there's an objective, but there's no product that exists, we need to know, or we would like to know, whether that's because there are a dearth of observations, or if there's a dearth of just people producing relevant products. And so knowing the applications from those the applications from the key products and services is going to be a really key piece of information there. Jason, anything you want to add?
I just wanted to say as a final piece is when we also do the mapping, we're then also able to talk with you and with other subject matter experts to understand there may be a product, it may be used to meet an objective, but it may not be sufficient for the full range of applications that we would like to have. And therefore, is that insufficiency due to temporal frequency of an observation? Is it to do with lack of a certain spectral band? Is it to do with the data latency? So we may have it and it may be good, but we don't get it in time to do a certain number of applications. So just having the mapping gets us pretty far to understanding what we currently have. Then taking it that next step helps us understand, is what we currently are, or are the products and observations we currently rely on fit for purpose? If not, why? And are there missing gaps altogether? Are there observations or products that we just don't have? And
so maybe with that, we'll open it up for discussion on these questions. And Sandy, I should say, if there are other things that you'd like us to talk about here, please feel free to chime in with those.
Great. Yeah, thank you guys. That was really detailed and informative, and I'm sure a lot of people will be happy to see your presentation up on the website where they can maybe piece through things a little more deliberately. I think there's sort of two levels at which we'd like to see this discussion move forward, and leaving your questions up there for the time being, what I might suggest is that the sort of overarching purpose of this discussion is really to try to understand what kinds of tools and resources and approaches we might have at our disposal as we're thinking about more of a framework approach to Arctic observing, and how we understand in particular the gaps in our current network, or how we kind of tell stories to the funding agencies and to the funding powers about what those gaps are. And so I think at a first level of the discussion, just letting people sort of reflect and think about this particular approach and what its relative, oh, sorry, turn my camera off, what its relative merits are as an overall approach, and how it might fit in with some of the other things that are out there already. The Arctic Observing Viewer as a tool that's captured a lot of information, those kinds of things. And, of course, I think everybody can clearly see, while the sea ice forecasting piece has been developed, there's a lot of other starting points that could be investigated as well. And so if you're not a sea ice person, I'd invite you to put your hat on about how those applications might play out. But then certainly the questions that are put up here for discussion very specifically to sea ice forecasting, there are sea ice experts on the call. And I'm sure we would be very interested to hear from you about that. I'll also note that we are doing some of this work through a task team. And if you'd like to be involved in the task team that really does the deep dives on this work, just please let me know. So that's kind of a lot, but I just want to give people opportunities to discuss more than the specifics here, or the specifics that are here as well. And I see we have a question in the chat from Bob, so we'll start with that. Is there a planned time frame for completing this analysis? Jason or Emily, do you want to take that one on specific?
Sure.
sea ice forecasting?
Yeah, sure. This is Jason. One of the things that we're working on with Sandy and with OSTP is thinking forwards towards Berlin in the fall. Is this a piece, we work with OSTP, they're putting together their priorities for the year, and some of the thought might be to flesh out the sea ice piece at least, or potentially another slice of this in time for that, and that's the October timeframe. There has yet to be a more formal discussion about filling out the entire Arctic assessment framework based off of that report that had been done, the full accounting of the 163 key objectives across those 12 societal benefit areas. But that's something that if there is interest in and from multiple parties, I definitely think that there is, at least at the OSTP level, from what we've heard from them, as well as in the groups that we've spoken to, some interest there. And if there's momentum and leveraging all of our connections and ability to work together, this could be something that we could tackle.
Great, thank you. Other questions from around the room?
This is Janet. I had a comment and a question. I like how the approach of, in the example that you gave, that the end result is the model and what the model needs. And maybe we could think of it going in the other direction, like reverse engineering it to be not, the model doesn't actually input all of these quantities. And so there might be observations that we get from a satellite, but the model is not ingesting it. And so I'm wondering if there could be a part of this exercise that looks into what is actually being assimilated in the models, and not just what's uploaded to GTS, but what the models are actually getting in for part of their product output. And then understanding if it's even in the purview of this study, what the contribution of each of those to model skill is. I mean, that might be out of the scope of this, but those studies do exist. For example, you can, satellite cosmic data or radiosondes will have an overwhelming contribution to model skill versus other satellite parameters, for example, but in the tropics. But I'm not sure I've seen that for polar sea ice. I'm pretty sure I haven't actually, but so I think that in answer to your questions, that undoubtedly this group could contribute to identifying some of those things. And I would just, given that the example that you gave was from the lens of a model, understanding what the model ingests and then produces from those parameters. And I'm not, this might be off topic, but, and maybe I missed it, but what is the polar sea ice model that you are referencing? Is it just a general thing, or is it a specific model?
Yeah, this is Emily. I'm happy to, so you bring up a lot of really good points. So I should say that the polar sea ice model that we're referencing here is, I would say, a composite of the sea ice modeling done by the Marine Modeling and Analysis branch of NCEP. So there are a couple different models that they reference, but this is kind of the expert that this elicitation was done with spoke kind of across their different modeling efforts to elicit the input. So to break down, I think one of the things that you brought up is the fact that not every input is going to be used to the same extent in a given product. And we absolutely gather this information through the Earth observation assessment, and similarly, NOAA gathers this input through the NOCEA process. essentially, when we do these elicitations, the first step is we ask everyone what the inputs that they use are. And then in a second discussion, we go through each one of those inputs and we ask, if you didn't have access to that input, how much would that degrade your ability to meet your requirements? And then we also ask them what your level of satisfaction is with that input. And so what we get is a pretty rich set of information about, I would say, both the criticality and the performance of any given input in service to a product. I think you bring up a really good point in that because we go from top down, we don't necessarily know if for a specific application, if an underlying model is going to use all of the inputs in the same way for serving one product versus another. We only kind of get that information in a top-down sense, so we don't entirely capture that. But we do get, in general, the impact or the reliance of any given product on its underlying inputs. And can show the relative reliance on one input versus another. We just don't have that information contained in the diagrams. Does that help?
Yes, thank you so much.
Yeah.
I would mention that I think that one of the conversations we were able to have just in some of this preliminary work regarding the underpinning observations for CI's forecasting was that if you don't apply the value framework lens, you often miss the point about the fitness for purpose piece. And so, as Janet pointed out, different models get applied to different purposes. Some might be applied to more of a marine transportation purpose, where others might be applied more to infrastructure risk assessment. And the underpinning observations might shift in a meaningful way in terms of which are really going to support that application. I'll pause there and say Bill Manley's put some good information in the chat related to the Arctic Observing Viewer, the research assets tool through the Alaska Ocean Observing System, and the upcoming resources that we're anticipating from Antaros. Bill, do you want to say a little bit more about how you think those resources might help with the census side of this work?
Well, the Arctic Observing Viewer, for example, is a growing catalog with a map-based interface that provides details on currently over 13,000 observation sites. I suppose it's more of a discovery level tool. It does provide links to more information for all those sites that span everything from buoys to flux towers to whatever. One thing that we're well aware of is that it's not complete. Even with over 13,000 sites, it's clearly missing a number of different observation networks and their specific locations and details. So it's growing as best we can. It's this whole goal that we share with others is limited by availability of interoperable information, I'll say. And it doesn't drill down to the level of detail, perhaps, that has been covered in this presentation. It would be great if it could. But a lot of it comes down to the interoperability of metadata among different fragmented sources. And so at this time, it can be also helpful to look at other portals or tools and to be in touch to establish linkages.
Thanks, Bill. That's helpful. And Emily and Jason, I think you can probably see the chat and copy some of those over, maybe to review internally to see if you have some.
Yes, thank you.
Yeah, some follow-up questions for that team.
And Jason and Emily, you know, Allison and I and others would be happy to get together with you, give you a little demo of the Arctic Observing Viewer or whatever, if it's helpful.
That would be fantastic.
Great, thank you. We can follow up.
Great.
Super. Any other questions? I'm in particular curious to hear more. I know that Jason and Emily would like to, be able to sort of retool this from what they did with the Earth observing view or the Earth observing assessment towards more of a tool for gaps analysis or really even just Arctic specific questions. Are there reactions or comments from the field on that point? So hearing none, I will mention that this will certainly be part of the conversation that will get more developed at the Arctic Observing Summit meeting in Davos, which is going to be in June this summer. We have mentioned previously in this setting that we are really encouraging contributions from the US side towards the short statements that they called for the Davos meeting. That deadline got extended again. So if you remain interested in contributing a short statement but weren't able to make the March 14th deadline, you can still get a short statement in, I think presumably if you did it by the end of this month. Any other questions? All right, well, hearing none and seeing that we're at the top of the hour, I really want to thank Jason and Emily for their presentation, for kind of grounding the group back in what we really mean by these societal benefit areas. I will restate the ask to this group that if you are interested in thinking about some of these other ways that we might expand upon this work or apply it, or complementary methodologies that you'd like to see highlighted in this discussion, I strongly encourage you to send us an email. As I mentioned, the specifics of the sea ice forecasting, we're going to be really organizing through a task team. If you'd like to participate in that task team, please reach out to me and I'll help you understand how you can get more involved in that. We do not, I think, have a date for our next meeting, but I can tell you that building off the Europe Polar Prediction conversation, that we're going to have our next meeting jointly with the atmosphere team and have a more in-depth conversation about the observing systems related to the Europe Polar Prediction, in particular the special observing periods. Jessica, do you have anything to add from the Secretariat side?
Nope, I think we're good to go. Meredith, Sarah? Sarah's not hearing. Oh, yeah, she is.
Nope, I'm good. Thank you.
Okay, thanks all. Thanks for a great discussion.
Thank you.
Bye-bye.
Thanks a lot.
Bye.
Bye.